Hey, everybody. Glad you could make it this morning, this afternoon, this evening, whenever you log on to this. And we're going to get started here with an overview of Venus and Mars. So this is an ultraviolet image of Venus. Now, pretty much if you want to see any detail in the clouds of Venus, you have to look at it with ultraviolet. And if you remember, ultraviolet is one of the wavelengths of light that is partially blocked by the atmosphere. And it's a good thing because ultraviolet in the higher bands of UV literally can sterilize, kill bacteria, and give you cancers. That's bad. Now, we do get enough ultraviolet light to get a sunburn, and you get enough to be able to take ultraviolet images of Venus. One thing I have found, I've tried to do ultraviolet with my backyard telescope, my 6-inch refractor, and glass itself blocks some of the ultraviolet light. And then here in Missouri, especially, we have so much water in the atmosphere, it tends to block ultraviolet light and it tends to block infrared light. So using a reflector that doesn't have any kind of glass that light passes through is a much better way to image Venus. This is a composite image, and the resolution is about 3 kilometers. The blue, which is supposed to represent oceans, is the low areas, and then when you get to the white, it's the highest areas. And there's a continent. If you look over on the left-hand middle of the globe, you see a continent, and this continent is Aphrodite. Now, if you didn't get the irony of that, Aphrodite is the Greek goddess of love that the planet is named after, which is Venus. And Venus is the Latin name for Aphrodite. So just a little bit of trivia that if you ever go on a game show, now you'll know. This is an amateur sketch taken with, I believe it's a 5-inch telescope, but I can't really tell exactly. And he's using 133 power and a SV Boni polarizing filter. And what a polarizing filter is, light comes in all sorts of wavelengths, but the polarizing filter is like teeny tiny slits in a filter, and those slits actually make all the light coming in either horizontal or vertical. And that means you cut down the amount of light coming in by approximately 50%. And what this does is with 133 power on a refractor plus the polarizer, it makes it so that it's not so bright. If you look at Venus with a small telescope, even at 133 power, it'll dazzle your eyes because it has a white, highly reflecting cloud surface, and it makes it very bright, and it's very difficult to see the details. So this is the Association of Lunar and Planetary Observers, ALPO, not the dog food, but the astronomy group. And it's a form, and you can download these and then print them off and then use them at the eyepiece. Some people actually put this on sketching paper so that they can get better sketches. And those are the really serious people who really enjoy doing sketching. And I have done some of this over the years, and it is really kind of fun. And if you have any interest, you can get a small telescope and do work like this without a huge amount of expense. This is E. Barnard with the Lick 32-inch refractor. And the Lick 32-inch refractor is a scaled up version of our 12 1/4 inch Clark refractor at Morrison. Now, this is a pretty good sketch, and Barnard is probably one of the more prolific observers of the late 1800s and the 1900s, early 1900s. And the other thing he did, though, he pioneered astrophotography, and he's the first one to take images of dark areas in the sky as well as the Milky Way. And so he was able to coax out some great images that still, some of them look like what you could do today using very crude equipment, which was state of the art in the day, but today it's pretty crude looking back. And here you can see a little bit of detail that he shows here. Now, just to be fair, some of this detail, unless he's using a blue filter, which I don't think it says that, at least I couldn't find it, um, some of that detail could possibly be your eye filling in, looking for detail. That's one of the negatives or difficulties with Venus is sometimes your eye wants to give you details that are not there. It just doesn't like looking at a white pearlescent crescent. It wants to see some detail there. So you have to be very careful and only draw what you know you see and not what you just think you see. And that's something you have to develop over time. However, this is a pretty good sketch, and very few people could do this that well. This is a guy named Ross, Dr. Ross. He used a photographic plate in 1928 that was brand new from Kodak, and it was ultraviolet sensitive. Now, in the 1930 to 32, Lowell Observatory was using blue sensitive photographic plates, but this was a ultraviolet sensitive photographic plate. And so the Pluto telescope did images in blue light, blue and green primarily, the upper levels of green and blue in specific, and red didn't really come out well, it was out of focus. So even though the Cook refractor that Tombaugh used, Cook design refractor lenses that Tombaugh used to take images of Pluto to find it, were corrected by three lenses. It turns out that it probably could have used these UV sensitive photographic plates, but Lowell decided to use just blue sensitive. So back in the 20s, early 20s, most photographic emulsions were more sensitive in blue and green than they were in red or ultraviolet or infrared. So if you notice though, Venus has some details, and this is over I think several months, June through July of 1927. So this was published in 1928, but the pictures were taken in 1927. And so you do see some change over time. And some people have tried to get a rotation of Venus based on the clouds. Turns out it really can't be done. It wasn't until radar came along and the Doppler of the radar that they were able to actually figure the rotation rate. So this is on the left is the Venera 8 Soviet spacecraft. When I was a kid, I heard it was made from the materials in a T-34 tank, and I think it's possible that a later one was used. I didn't look that up, but this is the first one to actually last on the surface of Venus. I think there was one that lasted 15 seconds, and the atmosphere of Venus ate it. You're going to look at a thing of the atmosphere here in a little bit, but the atmosphere primarily consists of hydrogen sulfide acid, and it's like 700 degrees Kelvin. I don't know, it's like 500, it's like an oven. So you take acid, heat it to 500 degrees, and then drop your car in it, see how long that lasts. There are not a whole lot of materials that can stand up to that. Plus, because of that carbon dioxide, which is the other part of what the atmosphere is made of, and hydrogen sulfide gas is so much heavier than nitrogen and oxygen that there's a really high pressure as well. And so the Soviets figured out that, when their spacecraft got eaten alive by the atmosphere, they had to do something. So if you look at the spacecraft and you see it says CCCP or CCP on the bottom part, that sphere was designed to withstand high pressures. And this is the one that discovered that the atmosphere had hydrogen sulfide, oh my gosh, hydrogen sulfide acid in it, clouds of hydrogen sulfide. And so this was really one of the first spacecraft to get solid evidence or info on what Venus's atmosphere was like. And on the right-hand side is a T-34 tank. And for those of you that don't know anything about this kind of thing from World War II, in 1941, the Germans, the Nazis, invaded Russia in what was called Operation Barbarossa, and everything went really swimmingly until the Wehrmacht, actually the tanks of the Wehrmacht, ran into a T-34. Actually, the first one they ran into is a KV-1, which is very similar to this. It's a heavier tank than this. And that tank blew up a whole bunch of German tanks, and it took a concerted effort of an entire battalion of tanks to actually knock the KV-1 out. And then when they met a T-34, not only was it faster than the German tanks, had a better gun, and it could withstand direct hits from virtually anything a German tank had. So these were well-designed tanks with heavy armor and a really great simple diesel. And the Soviets made thousands of these tanks. And in fact, people were still using them until the 20th century in the Middle East and Africa. And so, sometimes the electronics and things were updated, but the tanks were still in use. So there was a really good reason why there was a myth that they used a T-34 tank hull, melted it down, and make pressure container out of it, because these were really great tanks. And the Soviets had a lot of them. So this is the Venera 8, and then several things since then is showing the atmosphere, or at least the similarities of the atmosphere with the Earth. So global warming was popularized by Carl Sagan, who was a well-known astronomer in the late 60s, 70s, and 80s. And he wasn't the first one to come up with the concept of global warming, but because of his studies of Venus, working with NASA especially, they were able to extrapolate what was happening on Venus with a change of climate here on Earth. So you have Carl Sagan to thank for much of the global warming information that's out there. So the US put out a spacecraft called the Magellan, launched in 1989, arrived at Venus in 1990. I remember when that happened, it was a really big deal. I had little kids at home, and so it was kind of hard to follow. I was pretty busy back in those days, but I still followed it with some interest. And he began mapping the planet's surface with radar on September 15th, 1990. So I had a really close friend who was involved in the early 1990s with developing software, or really chips that would process. So it's image processing chips for radar, downward looking radar. And the idea was to be able to see things with a resolution of 1 inch or less. And what it was used for, they would put it on a fighter plane, they would fly over the enemy formations, it would shoot down the radar waves, and then this chip that my friend was designing would then be able to give an image that would show resolution of down to 1 inch. So you could tell exactly what kind of tanks, guns, almost what kind of bubble gum somebody was chewing. And so even though this was before he was doing this, this technology of the downward imaging radar came out of military studies from the 60s, 70s, and 80s. And so those that see no use in any military stuff don't actually understand that quite a bit of our technology today has come out of military studies. And so this was another one of those things. The downward looking radar could give its thanks to the Department of Defense, and many of their researches are funded by their grants. So in 1994, it was sent into Venus's atmosphere to burn up. It had gone past its useful lifetime and accomplished its global map with 98% coverage of the planet. I always figured the last 2% is probably where the Venusians lived, and we just missed it. I'm just kidding. All right, so here's some images. On the left is 25 or sorry, 50-kilometer craters on the right is where they think a asteroid or comet broke into pieces coming through the atmosphere, and then the multiple pieces hit. And this is pancake-shaped volcanoes on Venus. This is like a hole in the earth where viscous lava, see my hands coming up, comes out and then solidifies. And it's kind of a smaller form of an Earth shield volcano. This is the famous Miss Piggy corona. And the reason why it looks like Miss Piggy is not because, um, some giant alien presence made a Miss Piggy on Venus. It's because our minds are always looking for detail in areas that are jumbled or don't make sense. And so if you look at it correctly, you can see Miss Piggy in the actual round circle, and then the crater to the top left corner could be a bow on her head. So yeah, anyway, enough of that. This is showing evidence of tectonic forces, like the continents moving. So there apparently is similar, or has been similar, plate action like we have here on Earth. And this is about an 80-kilometer wide, 37 kilometers high, and it's showing cracks caused by tectonic forces. This is Venera 13, and the right-hand side especially shows what the light really looks like, and it's kind of reddish because all the bluer colors of light are absorbed coming through the atmosphere. And one of the things they found in one of the spacecrafts, I think one of the Soviet spacecraft, is when it came through, that there was very little light on the surface of Venus. It's a very dark place because the majority of light is being reflected by the clouds above. But they still get enough heat energy to make it 500 or 600 degrees on the surface of Venus. Here's the atmosphere, the mesosphere, the stratosphere, and then H2SO4 is hydrogen sulfide or sulfur clouds. And then CO2 under that. And notice the volcano. The volcano is pretty high, but it is not as high as Olympus Mons on Mars, which so far is the highest volcano in the solar system. This is one of the best photos of Mars taken from our planet, taken in June 2001 when Mars was only 68 million kilometers away. The resolution is about 20 kilometers, much better than can be obtained with ground-based telescopes, but still insufficient to reveal the underlying geology of Mars. So this is the Hubble spacecraft taking this image. And you can see some pretty great detail. And yeah, it's really good, but there is an image later on here that's almost as good taken with a telescope from the surface of the Earth. Here is Spirit rover on Mars. And one of the scientists that drove this thing came and talked to our school. And I had an invite to come up and actually drive the rover, but we never could get our calendars together. So I never had a chance to do that. But I think that would have been pretty cool. Just to say, yeah, I drove the Spirit rover one time. How cool is that? But we were in Espanola, and he was stationed at Los Alamos, which is like 20 miles up a hill. And so he was invited to come and talk to our students, and really, really enjoyed it. I really enjoyed talking to him and learned a lot. All right, Percival Lowell, 1855 to 1916. And just a little sidelight, one of the weird things when you get back into history is how people died. Percival Lowell had a massive stroke and died within 24 hours. Today, he most likely would have lived if he would have gotten the stroke shot in time. And I actually did a paramedic training one time, and I'm not a paramedic, but I was invited and I attended, talking about strokes. And the thing, if you recognize it's a stroke and can get them within an hour, the stroke drug that, you know, actually helps alleviate the symptoms of a stroke, people who have a massive stroke like this could possibly survive. My father died of a stroke, and it was not something that it was too bad. It was too massive to recover from, and so the shots didn't do him very much. But Percival Lowell had a stroke, was alive, but died within 24 hours. And so if you go back and you read the history of famous people for the first couple hundred years of the US, you have an awful lot of people having heart attacks and strokes. And so one of the reasons why we live longer today is because there's better treatment for those. And in a time when eating salt pork, bacon, and high carb meals was standard, finding out that it's not so much the salt pork itself, it's the salt used to preserve it. And the high carb meals go a long way towards causing heart problems. The sugar in your system, because your carbohydrates get converted into sugar, the sugar then damages the arteries, and the arteries then coat it with plaque in order to try to solve that issue. So one of the best things you can do for your heart is eat a low carb meal. And there's all sorts of stuff, and they've been talking about this stuff for 50 years. But just a sidelight, because Percival Lowell was like a lot of people back in those days, he smoked a cigar or a pipe and uh, ate lots of not so healthy food because that's what everybody had. And then he had a stroke. So I'm not saying that you will never have a stroke if you eat low carb foods. It's just something that might help as well, according to recent studies. So Percival Lowell was an interesting guy. Behind his back, they called him Uncle Percy. And there's pretty good evidence that Lowell, besides being a brilliant scientist and popularizer of astronomy, and a brilliant mathematician as well, was also somewhat of a womanizer. He married a gal, and then he had a secretary that he took with him everywhere, including to Africa, and his wife didn't go. And the first thing that happened after Percival Lowell died, his wife fired the secretary and turned her out, not even with severance pay. So pretty sure that Percival Lowell, Uncle Percy, had a pretty interesting time as a young man or as a scientist. However, a lot of people didn't like his science. He speculated too much, and he was convinced there was life on Mars and there was canals and all that. And it turns out to be an optical illusion. And we'll talk about that in a little bit. So this is Cassini's drawing of Mars from the 1600s. And notice there's not a lot of detail. And the reason is because he had one of those, let's see. Anyway, but Cassini used one of those 27-foot long telescopes with one small lens at the front. So the fact that he could see anything at all was pretty amazing. And so this is just a plate showing some of those things. And then it's talking about some other stuff. And you'd have to go look up the article on the Yerkes observatory site if you wanted to read the rest of it. And this is Dawes, and he was a famous scientist who looked at Mars, drew sketches of Mars, and then labeled everything. And he had continents and seas and all of that because the assumption was that the dark areas were actually oceans and the lighter areas were continents. And so this is, basically taking what we're used to here on Earth and extrapolating it to Mars. This is one of the many drawings of Percival Lowell. And one of the things to note is how straight the canals are. Now, this is the reason why he thought the canals were made by artificial, or not artificial, but intelligence. They were artificial canals, is because these had, they look so straight. But it turns out that there's a couple of different theories. One of the theories is he was actually looking at blood vessels in the back of his own eye. And when you get tired and the conditions aren't right, you can see lines that aren't there. The more likely is that these areas, some of them were small markings on Mars, and then the mind, to make order out of it, is bringing them into straight lines. And so he made these very detailed drawings, and you can see why he was convinced that there was life on Mars making these canals. However, E. Barnard and a number of other observers, when they would look at Mars, wouldn't see any of this stuff. And one of the other factors is the 24-inch telescope that Lowell had. He would usually stop it down to the size of our telescope, 12 inches. And they had a diaphragm up front that would shrink in size. And so he would make it like half the aperture that he could have used because he thought he got clearer seeing. And he would argue about that with just about anybody that would write him a letter about it. And the ones that used the full aperture of the telescopes never saw the canals. So it was probably the smaller resolution and the mind filling in the details that gave these canals. And then after a while, you kind of memorize where you think you see them. So pretty soon, every time you look at it, you're seeing those canals. And just as a side note, when I was a freshman in high school, I think, or maybe eighth grade, I had a 60 millimeter Sears refractor, which had really great optics, just not exactly a great mount. And I looked at Mars and thought I saw two of the canals. I was really excited, but it was the same thing. It's something I wanted to see, so I saw them. My brain filled in the details. And I can guarantee on a 60 millimeter refractor, there's no way that you would have the resolution to see a canal on Mars, even if it was 100 miles wide. So, yeah, it's a figment of our imagination sometimes. So, this is Percival Lowell. This is a more detailed map. And there he's put in what's called the albedo features, which means they're darker than the surrounding areas. But he's also put in his canals. And this is a globe, and I actually have a reproduction of this at home. It's a very small globe. It's like a 12-inch globe. And this is showing a network of dozens of canals, oases, and triangular water reservoirs that he claimed were visible on the red planet. And if you go back, you can see that this is probably the same thing. This was a drawing, and this was a globe, and they look pretty much the same. Antoniades canals, canal-filled globe on the left, and Hubble telescope image on the right. So you can see that there are some details that are similar. So if you leave out the canals, it's going, and you've just used lighter and darker markings, you actually would look very much like the Hubble Space Telescope image. This is images taken in 1988 when the planet was exceptionally close to Earth. This is Steve Larson, Lunar and Planetary Observatory, University of Arizona. I actually knew and talked to Steve Larson. My friend Rick Hill worked for Steve Larson for a number of years, and I met him a couple of times. So he was a very meticulous astronomer. He was head of the Catalina Sky Survey that was looking for near-Earth objects and comets that might hit the Earth for quite a number of years, but he also was a noted planetary photographer. And these are pretty good. If you notice, if you look, they're a little grainy. It's like if you take a teeny tiny picture on your computer and blow it up to screen size, it just looks kind of grainy. And that's because he used very high sensitive film to take these images. And the reason is because it doesn't have as much atmospheric blurring. So therefore, they're a lot sharper than what you would normally get from a photograph. This is an amateur image from a post on X. So this is just some guy in the backyard. I don't know how big his telescope is. He didn't say, but most likely like a 12 or 14 inch. And yet this is just something that you could do if you're a pretty serious amateur. Oh, that's interesting. I had it on there twice. And yeah, so when you look at it from this perspective, that's a very good image. And if you go back to this, it's really a better image than the black and white one that was taken by Steve Larson. So Damian Peach, who is a guy who's made a living photographing things in the sky, he actually has a course you can take on Kit Peak if you want to pay like $2,000, $3,000 and go and spend the night imaging with him. And this is an image of Mars from a telescope in Chile, and it rivals the detail of the Hubble Space Telescope. If you put them side by side, which I should have done, but I didn't, you would actually find that uh, the details are very similar. And, and here you're seeing a lot of things down to a fairly small resolution. So these are a bunch of drawings. The one on the left is a drawing of Syrtis Major by E. Barnard in 1894. And then these other ones are drawings. Mish, who's an amateur, 2003, Hatch, who was a gal who did a lot of sketches of planets. And then William Sheehan's written a number of books on the planets. And he is now is a retired psychiatrist or psychologist, don't remember which. And his, I thought, was probably one of the more detailed, but Mish is very good as well. But I wanted to show you the differences. So one of the reasons why imaging is so good or so important is because you get the same thing. So when you look at this, these are all more or less of the same regions, but you get different looks. You couldn't say they were all exactly alike. And if you remember, the importance of science is to reproduce the results of a scientific experiment. So when you observe a planet, that's a scientific experiment. And you have these three people who are pretty much looking at the same thing and getting three different results. And then you have Barnard, who's getting a different result. So consequently, that's why imaging was so important with the photographic plate, because you basically got the same thing when the planet was in the same position. And you didn't have any kinds of interpretations from your brain or your hands or whatever. This is from the Mars Pathfinder, and the Pathfinder and Sojourner, first wheeled vehicles on Mars, the size of a microwave oven. The later ones are much, much bigger. In fact, one is kind of was size of a small car that's still on Mars. But I just think it's really cool. There's places in Arizona or out west where you see stuff like this. And a friend of mine and I were dune buggying in Baja, Mexico, and there was an area that looked very much like this. Now there was green around, there was trees and bushes, but the actual ground, if you took away the trees and bushes, even the mountains in the distance look similar. So the crater in the Meridani Planum is 800 meters wide, making it slightly smaller than meteor crater on Earth. And note the dune field in the interior. So sands or blown dust have built up and shift around like a sand dune. And then the image shows the view from the Opportunity rover as it scouted the rim of Victoria Crater, looking for a safe route down into the interior. And just notice, I don't know if you can see the cursor, but notice there's layers here. And this really blew people away because so many people were not expecting any kind of layered formation on Mars. And yet this is some of the evidence of water having been on Mars at one time. Martian meteorite, this fragment of basalt ejected from Mars in a crater-forming impact, eventually arrived on Earth's surface. I actually have a teeny tiny piece of Mars in my collection. It's the kind of thing you almost have to have a magnifier to actually see, but if you take the lid off, you get to touch Mars. How cool is that? And this is a Mars map from laser ranging. That's where they shoot a laser down, and then as it reflects back, they measure the distance very accurately. And so if you notice, there's a crack here, and this crack goes about a quarter of the way around the planet. You could put like 100 Grand Canyons in that crack. It's a really big one. And what's ironic is that C.S. Lewis, writing a science fiction book back either before or during the war, the World War II, sorry, can't remember. He has the first book in his series of science fiction, and it's called Out of the Silent Planet, where two scientists and a philologist is one who studies languages. The philologist is taken as a sacrifice to the two scientists think that they need to bring a sacrifice and sacrifice it to these aliens that they find in a crack on Mars that goes quite a ways around the circumference of Mars in the book. And at the bottom is like a river and air and all this kind of stuff. So it's a pretty good book. I just thought it was interesting that I mean, there was no evidence of this at all until spacecraft went there between the 60s and 70s. And then they began, it's called the Valles Marineris. And when they actually went there, they found this crack. And C.S. Lewis wrote about it quite a few years before, not knowing it was there. So anyway, I just thought it was fascinating that C.S. Lewis got it right, kind of, from a science fiction book from a long time ago. This is Olympus Mons, largest volcano in Mars. It says probably the largest in the solar system, and it's Olympus Mons. And the interesting thing is once you get on the slope of it, this looks from space like it's pretty steep, and it is. I mean, it goes up 65 kilometers above, or 65 kilometers across is the opening on the top of it. And it goes up to like 89,000 feet above the surface of Mars. But it said that if you had a rover on there and you got up on the smooth part, you'd be hard pressed to notice the incline. That it looks pretty steep from space, but if you're there, it's not very steep. Look, I mean, it actually doesn't seem very steep, even though it is. And so I just thought that was interesting. But I always thought it'd be fun to land on Mars and climb to the top of that because you would pretty much be in outer space if you're that far above the Martian atmosphere. This is the eroded canyon lands on Mars, the Valles Marineris, 3,000 kilometers long and 8 kilometers deep. Again, dwarfs the Grand Canyon many times over. This is Martian landslides. The Viking orbiter image shows Ophir Chasma, one of the connected valleys of the Valles Marineris canyon system. You can see enormous landslides whose debris is piled up underneath the cliff wall. One of the thoughts is there may be water under the surface of Mars, and that every once in a while it gets warm enough to melt some of that water and it causes these giant landslides. There's other causes as well, so that's just something that's been discussed over the years. This is showing Viking 1 and Viking 2, and then with Pathfinder landed. Notice that they're very similar looking. It turns out, though, that the rocks there have some differences. And Viking 1 and Viking 2 were from the 1970s, and they primarily were looking for life on Mars. And the way they did the testing, one test showed positive results, but all the rest of them showed negative. And so there was a lot of discussion over the years as to whether they actually found life or not. The consensus today is they didn't find life. They found, oh my gosh, what do they call that? It's like it's like OxyClean, and you put something in it and makes it fizz. It's the same type of thing that's in the atmosphere of, or not atmosphere, but on the surface of Mars. This is water frost in Utopia. So frost does sometimes, it gets cold enough that the water does come out of the atmosphere. And these are from Mars Global Surveyor. And this is showing areas where dust devils have stripped away the light colored dust that show the lava rock underneath. And then the second one, sand dunes on Mars overlay a lighter sandy surface. And this is wind erosion on Mars. Long straight ridges called yardangs are aligned with the dominant wind direction. This is a composite image of the North Pole in summer obtained in 2006 by the Mars Reconnaissance Orbiter. And then the bottom one, or the one to the right, is the section of the layered terrain near the Martian North Pole. The mound's about 40 meters high that is sticking out of a trough in the center of the picture. This is evaporating ice on Mars, and it's a trench dug by the Phoenix lander in the North Polar region 4 Martian days apart in June 2008. So you can see that there's been a slight change in the amount of water ice that was frozen out. So you see runoff channels on the left, and you see Nanendi Vallis resembles Earth riverbeds in some, but not always. This is gullies in the wall of the Garni crater. This high-resolution image is from the Mars Reconnaissance Orbiter. The dark streaks, which are several hundred meters long, change in a seasonal pattern that suggests they are caused by the temporary flow of surface water. That's what I mentioned earlier. And this was evidence for liquid water on Mars. The dark areas are considered that it might be moisture or water that is coming out, and it's a salty liquid. So in other words, there's salt and minerals in the water that keep it from freezing, and that it melts enough to come out and then flow down the hill until it evaporates. Gale crater on the left, and then photographed by the Curiosity rover. And then geologists working with the Curiosity rover interpret the image of cross-bedded sandstone in Gale crater is evidence of liquid water passing over a loose bed of sediment at the time this rock formed. So on the right, B is another evidence of layered formation from water. And on the left, you see those flat rocks. That looks like a riverbed or a lake bed when the lake dries up and just leaves the bottom. All right, so this is the so-called face on Mars. There's a bunch of books written about it. The one on the left, notice that it does look like a face. But the one on the right, if you look at it, you can tell it's actually erosion. It's not actually a face that was carved there. And by the way, Carl Sagan was hoping that the face that you see on A, and he was one of the ones that helped determine where the global or the Mars Global Surveyor would go before he passed away. But basically, he was really hoping it was a face on Mars and that we'd have this great mystery that we would have to do. So he would have been disappointed by the results of the Mars Global Surveyor. This is the Ingenuity helicopter. They just decommissioned that not too long ago. And then the Chinese Zhurong rover deployed in June 2021 is next to the Tianwen-1 lander. And these were taken by a wireless camera placed by the rover. So the rover went out, put down a thing, then went back to get a selfie. How cool is that? So this is for your lab book. Why would a refractor telescope be better than a comparable sized Newtonian telescope for planetary imaging? So here's a hint. It has to do with how the telescope is designed, and there's two factors that would influence it. Now, if you only find one, that's okay. One of two is great. But write a paragraph or two about it and put it in your lab book. And the other hint is I haven't tried it, but you might try AI and see what it says. Put that in. Why would a refractor telescope be better than a comparable sized Newtonian telescope for planetary observing? But again, don't just cut and paste out of the AI. Write it in your own words. And that, boys and girls and others, is it. So I hope you have a great week, and I will see you. Today's Sunday, so I will see you a week from tomorrow in class, and hopefully during the lab time that night, it's supposed to be clear, but you know how weather is that far out. We should be able to look at the moon, and that should be pretty awesome for everybody, me included. I always enjoy doing that. So have a great week, and I will see you in about 8 days.